The ocean takes up nearly 70% of the Earth, and it's home to all sorts of wildlife. Recently, we've seen how plastic we throw away each day really affects the animals that live there. But what about the problems we're causing that we can't see? The ocean has become more acidic in the past few decades, and now we're producing more carbon dioxide than ever before. So here I have a glass of water. This is just normal water that I got out of the tap earlier, and this is a pH probe. Now this will measure how acidic or alkaline the water is. If the number is around 7, then it means that it's neutral, so that's in the middle. If the number is bigger than 7, then it's more alkaline, and if it's smaller than 7, then it's more acidic. So let's have a look at what this is coming up as. This is coming up at around 7.6, so that's pretty neutral. But watch what happens when we blow some bubbles into the water. So now we've had some fun blowing some bubbles, we can retest the pH of the water. Make sure we give it a good stir around so we get a good reading. And it's coming out as 6.2, so that's become more acidic. And this is because we breathe out carbon dioxide, so those bubbles were filled with CO2. And the water has dissolved the CO2 and become more acidic. And that's exactly what the ocean does to the excess carbon dioxide in the atmosphere. But to really understand why this affects the animals that live there, we need to have a look at how they communicate.
Hi, I'm Kirt the crab. Animals that live under the water like me use our sense of smell to detect things like predators. Oh, look out, there's one over there. Let's just keep a little bit quiet while he swims by. Okay. We use it to detect food when we're hungry, and we use it to find mates as well. Oh, look. Hi, Consuela. Hi, Consuela. Yeah. So it's me, it's Kirt. As you can see, I don't have a human nose like you. That would look pretty funny. If you want to know how this works, you have to come and have a closer look at my olfactory system. I have receptors on my skin that can detect certain chemicals in the water. When those chemicals fit the receptor, I can smell what's there. It's quite magical, really. Clams, my favourite.
Scientists all over the world are researching other ways humans are affecting the ocean. Dr. Jorg Hardege is one of these. He's a marine biologist at the University of Hull.
We're collecting shore crabs and hermit crabs for our research project. Crabs are very hardy crabs, as you can see in this environment here. It gets dry and hot and warm and cold and all these sort of things. But the trend over the last 100 years has been devastating. So their sense of smell is predominant. They detect it and then they respond to it. This is how a shark finds its food. This is how crabs find food. And that's why crabs can escape an octopus. So for them, really, switch off the smell. If you can't smell anything anymore, you're in trouble in the marine world. To see where we find a way.
Sometimes Jorg even has some helpers. Anyone can go searching for crabs on beaches across the UK. They like to hide in rock pools in places that are cool and dark, like under big rocks. But be careful if you're going to pick them up though, because their pincers could give you a nasty pinch. It's really important to put the crabs back in the rock pools later and always leave the big rocks where you found them. It's time to put those lab coats on because we're going to go and take these crabs all the way back to Hull University to go and have a look at them in the lab. And as if by magic, I am here at the University of Hull in the biology labs. Now behind me, I've got some very special tanks, and we're going to be putting some crabs into these tanks and seeing whether they detect the smell of food. And we'll try this in 2 pH conditions, one that is acidic and one that is the normal pH. Now this is the kind of chemical that the crabs have to detect. Now this is what it would look like in normal pH conditions, but when the sea becomes more acidic, it changes shape. Now if you think of this like a key in the lock, the key will no longer fit the same lock as before, so the crabs won't be able to smell the food. Inside these little holders are pieces of sponge. Now we've soaked these in some mussel juice, which is one of the things that crabs love to eat, and the other one hasn't been soaked. So let's see what this crab does in normal pH conditions.
The gradient is available.
Wow, look at that, she went straight for the food. We tested it with another crab to make sure that the first one wasn't just really hungry.
Hallelujah. You're looking for something. Look at that. Very aggressively looking for something.
Now this time Dr. Hardege put some CO2 into the water, which made it more acidic. Let's see what the crabs do now. She looks a little confused and is aimlessly going around the tank. And look, she even walks over the food. And just to double check, we tested it on another crab again. But how do we know this wasn't just a fluke? Well, we added some ocean buffer, which took the pH back to the same sort of level we had before. And watch what happens.
We didn't even wait 30 seconds, see?
The crab goes straight back for the food.
Okay.
But it's not just crabs. Sharks also use chemical cues to find all sorts of things under the water. And any animal that uses chemicals to smell in the sea will be affected.
Sharks have an absolutely incredible sense of smell. When male and female sharks are coming into breeding condition, they release hormones to let each other know that it's that time of year. And obviously if they can't detect those hormones, they won't know that it's breeding time, and they only have very few babies at a time. So if they're not breeding in the first place, that can hugely impact the whole population. They can detect as little as 1 teaspoon of blood in an entire swimming pool's worth of water. So if there are any little injured fish in the sea, the sharks can smell them. But obviously if their sense of smell is impaired or damaged in any way, they won't be able to find their food anywhere near as well, and that can really obviously affect them. This also affects the food chain as a whole, because sharks are really important. They're apex predators, so they're right at the top of the food chain. So if you take them out of the equation, everything else is impacted further down as well.
In the last 20 years alone, the carbon dioxide content in the air has gone up more than it has in the last 1,000 years combined. If each of us made just a few small changes, it could really make a difference. Walking instead of using a car, making sure we recycle properly, and using less electricity are all good ways to reduce the amount of carbon dioxide that ends up in the atmosphere. By making just a few sacrifices, we can begin to protect the habitat for the wildlife that live there.